Okay, girls, so I'm going to do the one about the string and the weights that was on your sheet. Apologies now if I hadn't done it with you. I thought I had. I'm very sorry. So you have two light and extensible strings of length 4 meters and 3 meters, and they're tied to a particle of weight 45 newtons, and the other ends of the strings are attached to a horizontal ceiling. Now you've got to show on a diagram the forces acting on the particle. Okay, so here's your particle. You've got a 45 newton force acting downwards, and then you've got these two pieces of string. So I'm going to call one of them T, that one, and I'll put the other one in red here, and I'll call this one S. So they're my two pieces of string. Now, that's the first part of the question. The second part of the question says write down the two equations that arise from resolving these forces horizontally and vertically. So here's force T, there it is. Now, I'm going to draw that ceiling across like that. Okay, so if I said that that string made an angle of alpha with the ceiling, then if I was to draw a right angled triangle around that force and mark its two component sides and call this one alpha because it matches that angle there, then if this is the string T, that's the hypotenuse. This side over here, which is opposite alpha, of course, will be T sine alpha. And this one, which is adjacent to the angle, will be T cos alpha. Okay, now I'm going to do the same with this string S. So here's my particle there. There's my string S. What I'm going to do now is break into its two components. So I'll have it going up like that and across, and of course if I had it going up and across like that, this angle here, I might call that one beta. So this matches this one there. So those two green lines are the ones I'm interested in. S is the hypotenuse, the force S. So this one over here, because it's opposite beta, is going to be S sine beta. And this one, of course, will be S cos beta because it's the adjacent. Right, so now look what I have. I have this particle, it has a 45 newton force acting down, and then it's got these two red components, T sine alpha and T cos alpha, and it also has these two green components, S sine beta and S cos beta. So S cos beta, S sine beta, and the red ones are T cos alpha and T sine alpha. Okay, I'm going to write down the equations. Now, from resolving those forces, I'm going to write down the vertical and the horizontal equations. So the vertical, if everything's stable, that means the up and down forces have to be equal. So T sine alpha plus S sine beta must be equal to 45. And the left and rights have to be equal, the horizontal ones. So this is going to mean that T cos alpha must be equal to S cos beta. Right, now solve the equations is the first part. So that's the second part, write the equations. The third part then is solve the equations and find the tension in each string. Now there's a bit of trigonometry to do. So we've got to get something for alpha and beta using these numbers here. So I don't know if you've done this now, if you've done trigonometry, if you finished trigonometry yet in maths, but I'm going to do this. So this is alpha, this is beta, 5, 3, 4. Now to solve alpha and beta, you can use one of the trigonometry formulas. The easiest one to use here would be cos rule. Now if you look it up in your log tables, cos rule for solving a triangle. So if you had any triangle, say if I call that triangle side A, side B and side C, that would mean that that angle there is A. So if I use cos rule applied to this triangle here, you'll look it up in your log tables, you'd see that A squared is equal to B squared plus C squared minus twice BC cos A. So I'm going to apply that to this one, these ones over here. Okay, so I'm going to find alpha. I'm going to use 5, 4 and 3 to get me some expression for alpha. So this is going to become 3 squared equals 5 squared plus 4 squared minus twice 5 by 4 by the cos of alpha. And I'm also going to get an expression for beta. So for beta it would be 4 squared is equal to 5 squared plus 3 squared minus twice 5 by 3 by the cos of beta. So I'm applying cos rule to both angles. So I'm going to use cos rule for those 3 sides in that angle and for those 3 sides again and this angle. And that will get me alpha and beta. Okay, so when I work this one out, this is going to become 9 is equal to 25 plus 16 minus 40 times the cos of alpha, which means that the cos of alpha, when I work that out, will become 4/5. If the cos of alpha is 4/5, then I know straight away that the sine of alpha, I just apply that, if this is an alpha, and if the cos is 4/5, solving by Pythagoras, this has to be 3, so that means that the sine of alpha is 3/5. If I work this out here, this becomes 16 is equal to 25 plus 9 minus 30 times the cos of beta. So when I'm bring out over these numbers here, that will give me minus 18 equals 30 minus 30 cos beta. So this will become 3/5 is equal to the cos of beta when I work that out. And of course, if I apply the same idea here, if the cos is 3/5, then using Pythagoras, this side here has to be 4. So if the cos of beta is 3/5, the sine of beta is 4/5. Okay, so I'm going to use these values now to solve, put them into these equations and solve for what I'm looking for. So I'm going to take this equation here, t sine alpha plus s sine beta equals 45, and the other equation was t cos alpha equals s cos beta. T cos alpha equals s cos beta, and of course I know all my values now. So t times the sine of alpha I found to be 3/5 and the cos of alpha is 4/5. So this is 3/5 plus the sine of beta I found to be 4/5, and that's equal to 45. So if I work this out, I get 3/5 t plus 4/5 s is equal to 45. And if I cross multiply, this becomes, if I cross multiply all the way across by 5, that becomes 225. Okay, now let's see what this one over here gives me. T cos alpha, the cos of alpha I know is 4/5, is equal to s times the cos of beta, which I know is 3/5. So this must be 4 t equals 3s. So t is 3/4 s. Okay, so I'm going to sub that now in here, and this will give me 3 times 3/4 s plus 4s equals 225. So that's going to be 9 over 4 s plus 4s equals 225, which will give me 6.25 s equals 225. So s is 225 over 6.25, and that gives me an s of 36 newtons. And then I'm going to find t. So t is 3/4 s, so that's 3/4 of 36. So that would be 9 3s are 27. So that gives me my 2 forces.